Let's talk about relations and functions, okay? So with relations are just kind of like a mapping, okay? It's kind of like relating. I know it's like using the word in the definition. It's relating two things. You're not comparing. You're just saying this goes to here. And a function is a specific type of like relation. So, Chris, do you want to move forward or do you like something? You sure? Okay. So, with relations and functions, there's different parts of it. Okay, we have the domain, which is which values, Lance? Yeah, in like lame terms. Like Mr. Harmon's pretty lame. Let me make it easier for you. This is the X or Y term? X. So domain is your X values, okay? And they're very important, okay? They're very important. The X values are very important. They're the input. So different names for your domain or like your X values, we got a bunch of them. We have input, you have domain, and you have X values. So you have three different names, and I will like interchange them just so you guys get the feel of it. It's not like you're in the middle of your SAT and it's the first time you're hearing like input. Not that it would be, but now for your range, obviously it's going to be the Y values. That's your output. Okay, so kind of think of it as like a machine. Okay, so a machine, you put something in and you get something out. Does that make sense to you? Okay. So a relation is a set of ordered pairs. The set of first components is the ordered pair is the domain of the relation. Okay. So like I said, you're just putting two things together, just two coordinate points. Sound good with that? Now, what is a function? Okay. Well, the formal definition of a function is, we use this like kind of crazy italicized stuff, is a set from A to B such that your X values like don't repeat. Okay. Let me explain it to you in a different way. Everybody here, including you guys at home, have used a vending machine, right? So why am I bringing up this? Well, a vending machine is a relation, okay? You essentially put your money in, you push some buttons, and you get something out, right? That's a relation. So kind of think of like, if you guys are looking at one downstairs, okay? And I always thought it was funny, but you're trying to get the pirate booty, okay? So you're trying to get the pirate booty, it's like A12. So you put in your dollar, you type in A, and then you type in 12, and you get the pirate booty, right? That is a function. Okay, why? Because I put in one input and I get something out. So for every input, I get an output. Now, what is the difference between that and a relation? Well, if I put in like A12, okay, if it's not a function, they can get anything out. Say I get the strawberry milk. And we all know Mr. Harmon is very fond of strawberry milk. I consider that a win, Nikki Grantland, but you might consider it a loss. So the difference is a function is for every input, you get exactly one output, okay? And a relation is just anything goes. I put two things together and that's what it is, okay? So down here, it simply just says, decide whether or not the description represents a function. So we're just looking at it. We're looking at the inputs, we're looking at the scenario, and we're just seeing if for each input, we get exactly one output. So it says, the input value X is any of the 50 states in the United States, and the output value, Y, is the number of governors of the state. All right, so let's think about that. So we picked Pennsylvania. Who's the governor of Pennsylvania? Wolf, right? So we picked Pennsylvania, right? And we got Tom Wolf. So that's kind of like so far 1-to-1, meaning we picked Pennsylvania and we got Tom Wolf. What if I picked, let's say, New York? Anybody happen to know the governor of New York? Starts with C, Cuomo. Okay, so New York has Cuomo. So that's also like 1-to-1. Now, how would it look if it wasn't a function? Ready for this? You ready for this, Kayla? Okay, now let's say I picked Pennsylvania and I got Cuomo. And I picked New York and I got Cuomo. That means I would have 2 states with the same governor. Is that possible? No. So for A, this is a function. It's a function because if I pick one state, I get out one governor. It's 1-to-1. B. All right, this one's going to be a little easier to see. Okay. So with B, in order to determine if it's a function, we simply look at the x values. Miss Puckett, do you see all those x values I underlined? Miss Puckett?
Yeah.
Do you see all the x values that I underlined?
Yeah.
Now I want you to pay special attention to them. Do any of those numbers repeat?
No.
No, so that's a function. So the telltale sign that something is not a function is if the x value repeats. So number 2 is a function. Let's look at C. Kailana. Look at C. Look at the inputs. Do you see anything about those inputs that might bother me? Yeah, it's a relation because the 3's repeat. So it's still like a mapping, but it's not a specific type of mapping. It's not a function, okay? This is like when you go down, okay? And you're going down to the vending machine and you put in 3. And this would say, hey, you could either get pirate booty or you could get the strawberry milk. Good luck. Does that kind of make sense to you? So yeah, it still kind of works, but it's not a specific function. All right, let's look at D. Jay Patel. Jay.
Yeah.
Which one of these columns is my input? Is it column A or column B?
A. B.
What'd you say?
A.
A. A is your input. Very good. Now, do you guys see how I have 2 lines coming off of A? Do you see that? Relation. Because I have 2 lines coming off of A. So it's kind of like just a different way of looking at it. So this is considered like a mapping, okay? It physically shows you that A goes to 1 and A goes to 2. So when you're looking at a physical mapping here in math, you're looking for 2 lines coming out of the same number. When you're looking at a table, Chris, you're looking at your input, your x values, and you're looking to see if any of those numbers repeat. Same thing with ordered pairs. Do you see that? These 2 things are exactly the same. So you're just really focusing on that first value, that x value. to determine. And then A is a real life scenario. Kind of like you just have to talk about it. Okay, and you have to think about it. Like I said, are there any two governors that are the same? No, not yet. So that's why it's a function. Okay. So there we go. Now let's look at the bottom. And let's talk about these. Which of the equations represents y as a function of x? Any ideas? Big grandpa's like, you got me. Here's what I need you guys to do. What's up, Lance? Okay. C? Well, why do you say C? Okay. All right. Okay. What if I said both of you were right? Not all of them. So A is a function. Y is a function of x. C, y can be written as a function of x, right? So what they're trying to say is in A, y is by itself, right? So when I put something in for x, okay, I'm going to get y out. Okay? So that's a function. That one's easy to see. Why is this one a little harder to see? Can I write that as a function? Yeah. I can do add 2x to both sides. I can write 3y equals 2x plus 4. Then I can divide by 3, right? And I get y equals 2/3 x plus 4/3. Okay? So Lynch, you are right. Now, why is this one different? Come on. The y is squared. So let's think about this, okay? Remember, it's all about what I put in, right? So let's think about it this way. So we put these in y equals form, okay? So let's do the same thing here. Let's get the y by itself. So we have y squared equals x minus 2. Okay? Now, what if I said, well, let's make a table. All right, x and y. What if I said y was like, let's say x is, what do I want to pick for x? I got it. What if I said x was 6? What would y be?
4.
Y wouldn't be 4. You're close though, Jake.
4 squared.
No? Well, x is 6, right? So y squared is 4. So what number squared is 4? 2. Well, what about, could it be -2 as well? So that's why it's not a function. So the thing about these are, whenever the y is squared, you're going to want to be hesitant about that, Caitlin. You're going to want to say, maybe, I don't know, okay? But here's an easy way to do it. Okay? The easy way is take your calculator, right? Take your calculator, and what I want you to do is I want you to type in y equals x squared plus 1 into your calculator. Take graph. You're going to get this, as Lance was motioning in class, U, right? And I want you to take your pencil, okay? I want you to take your pencil and I want you to drag it across your screen. And I want you to notice how many times does that graph touch your pencil? No, hold it vertically, Lance. Hold it vertically and just drag it across. Okay? Just hold it vertically, your pencil. Okay? Lance, vertical, other one. Yep. Okay? And drag it across. Hold vertically, drag it across. Doesn't your U only touch your pencil at most one time, right? Okay. Now, if we do that for C, we're going to get the same thing. But with B, okay, notice, Lance, because it's, you notice this x squared is that U shaped. So when it's y equals x squared, the U shape is this way, right? Up and down, it's like a normal U. But when it's y squared, it's actually like almost like a C shape or like a horizontal U. And that one doesn't pass what we call the vertical line test, which is something we'll be talking about. All right, so let's go over here. This one says, write a set of ordered pairs that represents the rule of correspondence. Winners of the Super Bowl in 2004, 5, 6, and 7. All right, so the solution is for the function that pairs the year from 2004 to 2007 with the winner of the Super Bowl. So it says 2004, the Patriots won. We know that. Were you guys alive then? Awful time. I believe that's when the Eagles faced the Patriots and we lost. Sad time. We were going to win and we lost. I cried for peace. The Patriots? No, they were just better. They're the Patriots. Nobody else. So that was 2004. 2005, the Patriots won. 2006, the Steelers. 2007, the Colts. Okay? Now I'm asking, would this be a function? What do you think?
Yeah.
Sure. Okay, does that matter? Does the Patriots winning twice matter? No, it's the year that matters. So the Y value doesn't matter. It's the year that matters. So in other words, Kailana, okay, it's not the fact that we have the same output like the Patriots, okay? The Patriots are allowed to win twice. They shouldn't be. And I hope they lose, okay? But that's okay. That is not what makes it a function. The other way, okay, the year is what makes it the function. So think about it this way. In order for it to be a function, okay, when I put in 2007, I can only get out one Super Bowl winner. And that is true, right? Every year there's only one Super Bowl winner. There's not like co-champions. It's only one. All right. The next one says the squares of all real numbers. So it's x and x squared. Is that a function? If I put in 1, 1 squared is 1, right? If I plug in 2, I get 4. That's a function. That's that graph that Lance was talking about, the U. All right, now for the fun stuff. Function notation. Now, I like function notation because, I don't know, it's just easier for me to deal with. Do you know that little like Y button you have? Okay, later on in math, it's only going to be like this thing called f of x. So let me read it to you. Hello? What's up? I do, but it's okay. that should be in like the math type. Yeah, if you do fill in the blank, you can't do that stuff and fill in the blank. Okay. Yes. Okay, bye. All right, so this, all right, in the notation, nothing. Right there. That is read as f of x, meaning literally a function of x. Now they're going to start using other letters like g, h, okay? But I like to start out with f because function starts with an f, and the notation f of x starts with an f, or an f. So f is the name of the function, okay? X is like the input value, and f of x is the range. So f of x just replaces the y. Are you guys okay with that? Have you ever seen it before? Okay. Real simple, not too crazy. So let me go through and start some of these examples. I wish they, that like y equals button, I wish they did away with that and just called it like f of x. Okay, like that y equals button is now being replaced with the function. Okay, so they mean the same thing. So like I could graph this. Okay, this is the same thing as saying y equals 3x minus 4. Okay, even though it says g of x, I think I'm still putting it in there. Okay. Oh no, what did I do? Oh, here we go. All right, watch this. So my function is g of x. That stands for 3x minus 4. So now what am I going to do? In order to find g of 1, I'm simply going to replace x with 1. So g of 1 equals 3 times 1 minus 4. That's it. And then, of course, I would simplify that to g of 1 is negative 1. Easy enough? Now, here's the thing that brings it all together, right? This is an ordered pair. The ordered pair is 1, negative 1. Cody, you with me?
Yeah.
So g of negative 2, well, now I just replace the x with negative 2. So I do 3 times negative 2 minus 4. So g of negative 2 is negative 10. So that point is negative 2, negative 10. All right. And to tie it in with the calculator, okay, you guys could go to your calculator. Like I said, Carolina, you could type this in. You go to y equals, type in 3x minus 4. Okay, if you go to 1 on the table, you're going to get negative 1. If you go to negative 2 on the table, you're going to get negative 10. That's where it is. Okay? Now, what does this mean? G of y. Well, it's kind of weird, but I'm just going to take x and replace it with y. That's it. So g of y is just 3y minus 4. What does d mean? Well, d means I'm just going to take x and replace it with x plus 1. So long story short, whatever is in these parentheses goes in verbatim for the x. Ready, Chris? See how this says x plus 1? G of x plus 1. I'm literally going to take that x and replace it with x plus 1. See that? Do you see how each time when I substitute it in, I literally put the parentheses with it as well? I think that's helpful. Now I can clean this up, Chris. 3 times x is 3x. 3 times 1 is 3. Minus 4 is negative 1. Okay? And g of x plus g of 1, well, that's pretty simple. G of x, okay, g of x is 3x minus 4 plus g of 1 was negative 1. All right, so I can use this work that I did over here. So this is just 3x minus 5. Laura, how do you feel so far? I assume that means good. No. Gotta get through this. It depends. Okay, if I say, so let me say it louder. Carolina asked, on a test, would I want you to write like g of 1 equals negative 1, or would I want you to write the point 1 negative 1? Well, if I ask what g of 1 is, okay, I'm most likely going to ask for like it would be like fill in the blank and you type in negative 1 into the blank. Does that answer your first question? Okay. If I asked what is the ordered pair of the function for the value x equals 1, okay, that would look like, okay, I'd give you the function g of x equals 3x minus 1, and then I would write when x equals 1. And then you would take that and you'd plug it in. It's just a different look to it. We'll go over all that stuff. Okay, Lance. Okay. So Carolina will go over like more of that stuff. Okay, it'll come up. So let me go through this a little bit. So we're at a good spot, and then I can kind of wrap this stuff up. All right, this one. This is a piece function or a piecewise function, meaning instead of it behaving in one manner throughout the entire function, you have one type of behavior in a certain area and another type of behavior somewhere else. Kind of think of like what's happening with the coronavirus right now. I know it's kind of weird and kind of like people don't like to talk about it, but here's what's happening with it. Is for a while over the summer, right? It was kind of flat. Agreed? Okay, it was kind of flat. So that was like one behavior of the virus. Okay, but before that, the virus like took off, it peaked, right? So that's another part of it. So that's like a piecewise. So you could actually divide it up into like 3 sections. You could say, hey, the first, say 2 months from like, or guess 3 months, March, April, and May, right? March, April, and May, the coronavirus was peaking. And then it hit a peak, and then it started to fall. That's another piece. And then it plateaued. So here, this is just saying, well, this function, f of x, behaves like x minus 2 when x is greater than 0. And it behaves like x squared plus 1 when x is less than 0. So this is what it means. Look at negative 1. Is negative 1 less than 0 or greater than 0? So when I plug in f of negative 1, I'm going to plug it into that one. And I'm going to get, what is that going to be, 2? Sound good? Let's look at 0. Where does that fall? Does that fall on the top or the bottom? The bottom. So when I plug in f of 0, I'm going to plug it into that one. Oops. Chris, where does that fall? In the top function or the bottom function? Very good. So I'm going to go ahead and I'm going to plug that into this function. So I get 5. Now for the last one, we have 2 parts. So f of -3 falls into this piece. Okay? So I plug it in there, and I get 10. And then it has this piece, which falls into here. And then I can combine the two by doing 10 plus 2 and getting 12. I know there's a lot going on. All right, to recap it all, you have a relation, which is just like a mapping. This number goes there. Then you have a function, which is kind of like a snack machine. I put in money, I type in my code that I want, and I get out what I want. You have domain, that's your x values. You have your range, that's your y values. X values are also called inputs, y values are also called outputs. Functions, they need to hold true to the vertical line test, which is something we're going to go over. And then we have this function notation. All right, that's what we got. See ya.